Before we go to the demo, let's understand how an application gateway works and what are the different components of an application gateway. So, if you see on the diagram on my screen, here we have the user or the client. Now, before they can connect or send a request to the application gateway, they have to resolve the domain name of the application gateway. Okay. The Azure DNS will return the front-end IP of the application gateway. So the first component of the application gateway is the front-end IP. Now, if this is a public or internet-facing load balancer, the front-end IP will be a public IP, okay, and either it can be static or dynamic. But if it is an internal load balancer or the application gateway is working as an internal load balancer, the front-end IP will be the private IP. Okay, and the application gateway accepts connection from the client on a listener. There has to be at least one listener associated with the application gateway. Now, this a listener is configured with the front-end IP. Okay, it's associated with a port and a protocol. Okay, so what is the listener? Now, listener is a logical entity which is accept or check for connection from the clients. So to give you an analogy, assume that application gateway is an house which has an address. The address in this case is the IP, the front-end IP of the application gateway. The listener acts as a door. It checks who is knocking on the door, on which door, and whether if they are allowed to knock on that door or not. If they are allowed, it will accept the connection. Okay, it will accept the request or the connection from the client or the user. Okay, now which door is the port here? Now the port can be HTTP, that is port 80, or HTTPS, which is 443. Okay, now and if you are using a web application firewall, the request header and body will be checked with the web application firewall rules to check whether it's a valid request or a security threat. Now, the web application firewall has two modes, whether prevention mode or a detection mode. If it is in prevention mode, it will block the traffic as a security threat. But it's only in detection mode. It will create a log for the traffic, but still, the request will be forwarded to the backend pool. Okay. Now, after the listener, we have routing rules. This routing rule determines to which backend pool the request will be routed to. Okay, now the routing also determines on the protocol or the port, right? And which backend is healthy, right? Okay. So also because before the request is sent to the backend pool, a new TCP connection is established with the backend pool. The connection with the client is terminated. So your client or the backend cannot see your client. So this offers a extra security layer in your load balancing solution. Okay. Now your backend pool can be either a virtual machine scale set, or it can be an application running on your premises, or a web application hosted in Azure App Services. Okay. Also, the application gateway add additional header to the request before it is forwarded to the backend pool. Okay. And unlike like we have discussed with other load balancer, it also has a health probe, okay, to check whether the backend pool is healthy or not. Now, this is not the health probe. This is the HTTP or HTTPS setting, which is used to connect to the backend pool. As I said, there is the application gateway will establish a new TCP connection with the backend pool. Okay, that is why it is also called as a proxy load balancer or a proxy server. So this is how the application gateway works, and these are the different components: the front end IB, the web application firewall, listener, pool, backend pool, HTTP setting. These are the different components of the application gateway. Now what we will do is we will see a demo of how this application gateway works. I will configure this in Azure portal.